3.1 exponential and logistic functions. So this is kind of like its own category on the AP exam. And trig is kind of its own category, and then the stuff that we just did is kind of its own category. It's made up of like 3 basic units of stuff, and so this exponential and logs are like a whole unit itself, but it's a shorter unit, at least in our textbook. So, get to the correct page here. The first problems want us to say if the functions are exponential or not. If they are, state the initial value and the base, and if it's not, explain why not. So number 2, y equals 3 to the x. Is this exponential? So totally different rules than polynomial. Yes, exponential functions will have a variable as their exponent. So this is exponential. So I need the initial value and the base.
Is the initial value 3?
Nope. So the base is 3. So whatever the number that's being raised to the power, that's going to be your base. So the base is 3. The initial value is just 1. Which pretty much always that's the case. So an exponential function can't have a variable as a base, and essentially it needs a variable as the exponent. Can't have like a radical exponent or something like that though. Come back. 4, y equals 4 squared. Is this exponential? Bella says no. Why not? No variable. It's just a constant function, so not exponential. Constant function because it's just equal to 16. Six y equals x to the 1.3. Is this exponential? All right, the variable is the base, not the exponent, so this is not exponential. This is actually a power function. All right. Next one, say to compute the exact value of the function for the given x value without using a calculator. So number 8, f of x equals 6 times 3 to the x for x equals -2. So just to go back, the initial value, none of these had one. I mean, other than it, like the first one was just 1. The initial value of this problem would be 6. Okay, because that's if x is 0, what value do we have? So it would be 6 would be your initial value on this one. All right, so we just plug in -2 for x. So I have 6 times 3 to the -2. What's 3 raised to the -2? What's the negative exponent do? It flips it, so this is going to be 6 times 1/9, which gives us 2/3. 10. F of x equals 8 times 4 to the x for x equals negative 3/2. So plug that in. 8 times 4 to the negative 3/2. So just like the last one, the negative, it's going to flip it to the bottom. So this is going to be 8 times 1 over 4 to the 3/2. But what does the exponent of 3/2 tell us that we're going to be doing? Like, walk me through what that means.
It's gonna get small.
Like, mathematically, what's happening? So what does the 3 power do? Like, 3/2. What does the 3 tell me I'm going to do? Gonna cube it. What does the 2 tell me?
Square it. You don't have that.
Put it inside.
What do you mean?
Put it inside the cube root.
So square root.
Oh, wait.
So the bottom.
Would you multiply by
'Kay.
4?
So if I had 8, or let's do this. 16 to the 3/2. This means take the square root of 16 and cube it. So that would be 4 cubed, which is 16 times 4. What is that, 64? Something like that. Okay? So what's happening to this 4?
Take the square root of it.
And then what?
That's your answer. It's over, like, under 1.
So all you told me to do is take the square root. What do I do with this 3?
Cube it.
Take the square root of 64.
No. This is irrelevant. I'm just showing you how to use it. That's not what we're doing. Take the square root and then we cube it. So what is the square root of 4? So this is 1 over 2 cubed. 2 cubed is 8. 8 over 8 is 1. Alright, I go back and forth every year on this problem if I'm going to show it or not, but I am going to go ahead and show it to you, but I wouldn't really easily be able to give this to you on a quiz or a test. This is more just informational. I don't think they would give it to you this way on the AP exam either, but just so that we have it. It says exercise 11 and 12, determine a formula for the exponential function whose values are given in the table. So 11 is f of x, 12 is g of x, so all I'm going to write in the table is the g of x values for you. So we're dealing with g of x. So the table gives us x and g of x. So x is negative 2, negative 1, 0, 1, and 2. G of x is 108, 36, 12, 4, and 4/3. And we are trying to write a function that is a times b to the x. Okay? Oh, sorry, you can't see the whole thing. There we go. So I need to figure out what the initial value is. Does anybody know what the initial value is based on what I said a minute ago about the previous problem?
Of that thing.
Okay. Yes, we're trying to solve for a.
Okay.
So what's the only way to have a by itself when x is what?
Oh, you said it equal, or you like put it to the power of 0.
So when x is 0,
Oh, so it's 12.
so 12 is a. So I'm going to write this right here. Okay. So I know that I have 12 times something raised to the x. So I need to figure out what b is. So the easiest one is when I plug in like something, I need to figure out what's getting me to that value. So basically, what raised to, let's say 1, when I multiply it by 12, gives me 4. So basically, what number times 12 equals 4?
1/4.
It'd be like -3.
Oh wait, 1/3. Wait, what? Oh yeah, -3.
-3 times 12 would be -36. I need it to equal
3.
4.
We're saying to the
Negative
power
1/3.
of it though. To the power
Well,
of
not negative, but 1/3.
Oh.
Yeah. So, I'm figuring out, okay, if x is 1, this table is telling me all the values. So when x is 2, it's equal to 4/3. When x is -2, it's equal to 108. So, I figure out, okay, what number, when I raise it to, the easiest one to deal with is 1 besides 0. So when I raise 1/3 to the 1, that's just 1/3 times 12, that equals 4. So you're just trying to figure out what number essentially is b. That kind of makes sense. Sort of. Not really. Tristan says no. So if I took, let's say, once you've come up with this, take -1. What do I get? Ignore the table. What do I get when I plug in -1 for x? So if I had 12 times 1/3 raised to the -1, what do you get?
3.
36.
So, yeah, 12 times 3, which is 36. Now, go to the table. X is -1. Oh, it's 36. So I know that this is legitimately what I'm trying to find. The easiest one to do it for is just 0 to find your initial value and then 1 because nothing's having to flip. So it's kind of like a guessing game a little bit, which is why sometimes I do this and sometimes I don't. But these ones actually aren't too hard overall. Okay. All right, the next problem, state whether the function is an exponential growth function or an exponential decay function and describe its end behavior with limits. You're probably like, oh yay, limits again. So just as a refresher for you, I think this probably was in your notes, but just to make sure we have it. If it goes like this is exponential growth. If it goes like this, that's not really a good picture. It is exponential decay. So I'm looking at basically as x gets really, really big or really, really small, what's happening to the graph. So your options for what your limits equal is either going to be 0 or positive infinity. We're not going to have any that are going to negative infinity. These are all just going to be like normal looking graphs. So 32 f of x equals 1 over e raised to the x. So kind of a good way to think about this is pretty much if this is a positive exponent and you have a fraction here, it's pretty much always going to be decay. Okay? Because as this number gets bigger, it's like x squared, x cubed, and so on and so forth, this number is going to be getting smaller and smaller and smaller. So it's going to start big, quote unquote, and then it's going to get smaller and smaller and smaller. Okay? So this one will look like this graph up here. Okay? You can graph it on your calculator if you want to see it. So this is decay, and you don't have to write exponential. You can just write growth or decay every time. So then I'm going to look at the limit as x approaches negative infinity of f of x, and I'm going to see what happens. So let's just hypothetically say here that put in -5. Like, I don't even have to go super crazy. I just need to go in the negative direction. So if I have 1 over e raised to the -5, what is that going to end up being? You don't have to give me an exact number. Just rewrite it in terms of e and an exponent.
You would be on top.
So it'd be e to the 5th power, right? Does anybody know approximately what e is? Anybody want to guess? Everybody give me your guess.
It's a decimal, right?
Depending on what you mean by that, yes. It's irrational, so... Huh? Let's just go with this. Is it bigger or smaller than pi?
Small.
Smaller.
In the twos.
Yes.
3, 5, 6, 4.
2.7. 2.717. So, let's just hypothetically say it's 3 because it's close enough. 3 to the 5th is what? Okay, what's 3 to the 4th? 3 to the 4th is what? 3 times 3 times 3 times 3. 81. Okay, so 3 to the 5th is bigger than that. So, where's this going? Infinity. Now, if I had the limit as x approaches infinity of f of x, so let's just say on the flip side, let's just say that x is 4. Nice and easy to work with. So I have 1 over e raised to the 4th. I can even go as far as to say that's approximately 1 over 81. Because we said e is 2.7. You can round it to 3 just to have a whole number. So, what is that going to get close to? 0. So that one's 0. So one of them is always going to be 0, and one of them is always going to be infinity. The only way that might look different is it could be negative infinity if this number was negative. But we don't have that situation. All right, now I'm going to modify this problem, and then we'll do one more after that. So if I modify this problem, f of x equals 1 over e raised to the negative x. Is this growth or decay? Why?
Because it's like flip it and it'd be positive.
Yep, so it would end up being e to the x, which would be growth. And then if I did the limit as x approached negative infinity of f of x, so let's say I put in -4. What's happening? So this is like e to the -4. What's that approximately equal to?
Negative.
1 over 81. Okay, we're just doing rounding. So, as x goes to negative infinity, what is this function getting close to? 0. The limit as x approaches infinity of f of x. So if I did e to the 4th, this is approximately 81. So this one's going toward infinity. So you don't have to pick like a giant number. In the polynomial ones that we were doing in the last chapter, you needed to kind of pick a big number or a number that was, depending on what thing we were dealing with, to the left or the right, really, really close to the number that we were given. These ones you don't have to pick something drastic because exponential problems happen so quickly that you can even choose a number that's close, that's something easy to deal with, and it's not that bad. Let's see. 34. F of x equals 0.75 raised to the negative x. So if I get one like this, I prefer to deal with it as a fraction. So how could I rewrite 0.75 as a fraction? So I would rewrite this as 3 over 4 to the negative x. Is this exponential growth or decay?
Oh wait, no. Growth.
Why?
Because since it's a negative exponent, it makes it positive.
Yep, so 4 over 3 raised to the x. So that would be a number bigger than 1, so that's going to end up being growth. So then I would just use this manipulated one here when I'm doing my limit. So limit as x approaches negative infinity of f of x. So let's just say 4 over 3 to the negative 2. What does that give me mathematically? Four over 3 to the negative 2 is not 0. 9 over 16. So the exponent that's negative tells me to flip it and then square it. So 9 over 16. So what is that getting close to? 0. The limit as x approaches infinity of f of x. So we can just even choose positive 2. So 4 over 3 raised to the 2 is 16 over 9. So what is that going toward? Infinity. So even if you possibly didn't know if this was growth or decay to begin with, the limits give you a visual picture. So let's just say I had no idea what that was, okay? As soon as I see as x goes to negative infinity, it's 0, then I know that by just looking at that, I don't even have to know all the values. I know that it's starting down here. As x goes toward infinity, it's getting bigger, so I know that it's going up like that. So then at this point, I can see clearly that it's growth, okay? So that's why we're doing the limits, is to verify that what you're saying is the case is really what's happening, okay? And that's really all for this section. There's nothing really super crazy in this section. So problems 1, 3, 7, 9, 11 is going to be like 12. 31 and 33 will be like the ones we just did. And then, just for fun, a multiple choice problem, number 63. And make sure you have 3.2 notes for tomorrow.